good session from Dr. Jagan covering most of our products. We have another speaker. She is from Gilson in USA. Basically, she is a application analyst of Gilson. She has been working with Gilson for last 10 years. And Gilson is a company manufacturing different type of automatic liquid handlers, mainly auto liquid handlers. You might have seen many of the Gilson pipettes and other things in the market. So we have been promoting the automatic liquid handling. And going forward, Dr. Gomati, she has been a PhD from chemistry, and she has been working on this Gilson for last 10 years on this type of liquid handlings. And she has been working with different companies and different customers, different type of customer, starting from food or any industry. She has been doing a job of fixing the requirement of the customer with reference to the instrument. This is a major profile. Now she has come here to talk about the automatic solid phase extraction system. Gilson has many solid phase extraction system, automatic system for different applications which our Gomati can. I request Gomati.
Alright, thank you very much for the kind introduction. Something very interesting happened yesterday. So I was visiting some customers here in Chennai, and then usually when I go to other places, other countries, other laboratories, even in India in the north, I'll be talking in English normally. But yesterday I was talking with Tamil. So okay. So it was very interesting and it was very refreshing, and I am very happy to be here in Chennai and then talking about our products here. And on that note, thank you very much for all of you coming here, joining for this seminar. I know it's time is valuable, and you have given your valuable time here joining us today. And then I am Gomati Chan. I'm actually based in Kuala Lumpur, Malaysia. So I think it's a famous city, right? All of you know that, Kuala Lumpur, in Malaysia. And then I am hired by Gilson, Gilson US. So I'm representing Gilson US. I'm the field application specialist covering all the automated products. And I am covering Asia, like China, India. Okay, sorry, no more China. China, we have a separate Gilson entity in China. So like India, Japan, South Korea, and then Australia, and other Southeast Asian countries, and also part of the Middle Eastern countries. So I have been working with them for 10 years right now. And today, I will be especially talking about Gilson aspect system. How many of you know about solid phase extraction, SPE? How many of you know about the technique?
Everybody must be knowing. They were from food testing, so most
Exactly. So you know about the SPE. So if you know, you should have just put up your hand. All right. You just close the lights. Okay. Right. So you know about the technique, and then today I will be talking about in detail about all those techniques. So you have the SPE techniques. You have 4 stages of the SPE steps, right? And then all those 4 stages, you need to have different flow rate, different pressure, in order for you to have a good reproducible result. So I assume a lot of you do SPE, and then you're using the manual liquid manifold. Is that correct? The manual SPE. You're using with the manual SPE. and you are using the negative pressure. So I will be also explaining to you what are the advantages about the positive pressure as compared to the negative pressure. So we'll go into the presentation. Alright, so we'll be talking about why we actually need the sample preparation, solid phase extraction, the basic principles and the concepts, Gilson SPE portfolio, highlighted SPE applications in food and food safety. Alright, why sample preparation? Okay, I think it's a dream of all the extraction chemists to just take the sample and put it in the analytical instrument and then get your results. So that's a dream, right? You're not actually going to have that. So a lot of our food, let's say simple water. So even water, you have your contaminants inside. Let's say you have your pesticides inside. But then it's very much diluted. So you just take like 10 mils of sample, you try to do the analysis, but you will not get the result that you want, the pesticides, the contaminants that you're looking for. But it's there, but it's just in a very diluted state. So what you need to do, you need to have a proper extraction technique. You need to have a proper cleanup technique. So why? So first of all is the matrix effect. So the impact of the compounds detection and also analysis in mass spectroscopy like LCMS. So matrix effect is the difference between the detector response for an analyte in a standard solution and the response for the same analyte at the same concentration in a sample matrix. So your matrix, it will actually suppress whatever signal that it has. So in a pure standard, compared to your matrix, if you just inject it like that, you will not get a same sample signal. So analyte and sample compared to analyte sample, standard and sample, it is different. So you need to have an extraction process, you need to have a cleanup process for that. The concentration. So as I mentioned, let's take wastewater. So you want to identify some contaminants in the wastewater. The concentration level is very low in the wastewater. So what you need to do, you have to get the reach limits of this detection and quantification for analytes at trace levels. And you have the calibration curve, which is required for quantitative analysis. So before concentration, you will, in the original sample, you will have just a minute peak. But after the concentration, you just get rid of the wastewater, and then you will have your contaminants there of your interest, and you just dilute it with small amount of organic solvent. So usually we'll use organic solvent for the next stage of analytical instruments. So you can have a good signal enhancement there. And then analytical compatibility. Okay, so dilution solvent use must be compatible with the analysis solvent strength, or an elaboration step will be needed. The sample preparation protects analytical systems from killers and reduces maintenance frequency. So let's say your original sample, it has some killers like salt. So if you inject that into your analytical instrument, of course, that system will be spoiled. So to prolong the lifespan of those analytical instruments, of those columns itself, you will need a cleanup technique. Simplification. Okay, so you have in your food sample, you have a lot of different types of material, different types of contaminants. But you are looking for a particular material. So let's say you just want to identify certain class of pesticides. So you have a method, SPE method, or any method, to extract out just that type of contaminants, pesticide, from that food, and you analyze them. So your life will be much more easier compared to just extract everything, and then you just run it on the system, and you get so many peaks like this. So you get so many peaks, but after the cleanup process, and then you just get the pixel what you want to. So that is some of the reason why you actually need to do the cleanup step. Okay, so which approach for you to use for the sample preparation? So analytics. So it depends on the downstream detection system as well. How sensitive is your detection system? What are the selectivity for your detection system? The limit of detection, limit of quantification, and also the concentration range that you can work on. The target compounds. So compound, whether it's a known target compound or whether it's an unknown target compound screening, and then your downstream analytical instrument, they need to have a library to identify those compounds. The throughput. So sample numbers to be analyzed and also easy automation is planned in the future. So you have a variety of your automation system. So which automation you choose? And then if you have a lot of sample, might as well you just go onto the automation, just to make sure that you have the reproducible steps going forward with that. So before that, if you have a lot of samples, and then if you're relying on a technician to do it, so he can work from day to night for the whole day. But if you want him to repeat the whole process maybe next day over a couple of days, then maybe the result won't be as precise or reproducible as it is. If you have automated the whole thing for the throughput, each of the time, the automation system, it will have the same flow rate, the same pressure, the same solvent volume, exactly the same, just it can do the reproducible result. It can give you the reproducible result over the few batches of samples that you have. And then, of course, the cost. Internal competency to develop method versus outsourcing. The sample preparation time versus analytical downtime or error risk, and also the consumables. So certain companies, so they may have some samples. And there's certain outsourcing companies like testing labs, like food testing labs. So you have the instrument. So you see the sample, you have that method, and you will just run it. So the person in charge, they will see, okay, is it better for them to do it themselves, or is it better for the outsourcing? So outsourcing, we have done a lot of different samples, and you have the required experience as well to do the whole thing. The SPE, the basic principles and the concept. So this is the most interesting part. Alright, so typically here we'll be talking about solid phase extraction SPE. So the typical protocol, separation or removal of analytes from a mixture of compounds by selective partitioning of compounds between a solid phase, which is the solvent, and also a liquid phase, which is the solvent passing through. So here, the advantages. So it has high selectivity. So let's say you need to find a group of pesticides from a lot of other contaminants. So you just have a method to be selected on those particular groups. High recoveries and good reproducibility. So as I mentioned, SPE itself, if you follow the protocol, and then it will always give you a certain high recovery because you're targeting a certain group of compounds. Large application field with the methods and analytes, and it's available for automation as well. So we have the steps, we have the steps to do the SPE, and it is very much prone to the automation. Low solvent volumes. So we'll be working probably about 10 mil or less of the solvent for each of the steps. Disadvantages, okay, it is perceived as complex. Like the method development, you need to develop a correct flow rate or a correct equilibrium parameters or the volume of solvents that you need for that particular method. So once you have developed that, the further steps are just automatically done. And then cost per sample. So you have been using the cartridges So the cartridges, we are not cheap as well. So if you have a method, you would want to use these columns to do it as precise as possible. So meaning that you don't want to waste the cartridge as well. Alright, so analogies and differences. So you have a lot of different solutions. And then here, the matrix of the sample between solid phase extraction and liquid chromatography. So it is a solution. And then here, for the solid phase extraction, the subplot will be the surface. And then the technique, it is the liquid adsorption technique. So, liquid chromatography, so something like HPLC, it is a continuous dilution. So meaning that you have your, let's say 100% ethanol, you want to go down to 50% ethanol. So you have a continuous gradient dilution of your solvent onto that column. But then for solid phase extraction, it is step dilution. So first, you will dilute with 100% methanol. After that, maybe 80% ethanol. And then after that, maybe you can go down to 50% ethanol. So it is step dilution. It is not gradient dilution. And then the columns. So you all have been working with HPLC. You know the HPLC columns. And then solid phase extraction columns. So they are coming, they come in cartridges. And the particle size, it is around 30 micrometer to 90 micrometer, and the packing, it is between somewhere 10 milligram to 10 gram. And compared to HPLC, it has a lower back pressure. So HPLC can go up to UHPLC as well. So it has a very high, it is a very high pressure system as compared to the solid phase extraction. Alright, so the solid phase specifications, different brand. So different brand, it makes a lot of difference as well. So the brand A and brand B, okay, the functionality, the group, it may be the same, CAT. And then the particle size, okay, so it can be, okay, it differs. And then the pore size, it matters. The most important thing is how well it is packed. Let's say brand A and brand B. Some brands, it is CA2, yes, but then the sizes, the packing material, the size, it is not uniform. So if it is not uniform, batch to batch, you will not have a reproducible result. So you want a result, you want a good result, you have a good method, you have a good method, you have a good system, you have a very experienced technician to do it. But then, if your column, it is not of a good quality, you will not have a good reproducible result. So, the column, it depends, the cartridge, it depends the quality. So, the different particle size in one cartridge, or it is an evenly distributed particle sizes in that one cartridge. So fine particle includes uneven flow inside the cartridge with preferential pump which impacts directly to the loading capacity and also solvent volumes. So here it will give you a bad separation compared to a good cartridge. So evolution, mainly still we are using a lot of CAT cartridges, silicon cartridges. So apart from that, depending on the application, we have many different types of the cartridge base. So you have ionic exchange cartridges, and then you have affinity cartridges, you have Borasil, and Vinyl, and up until lower chain carbons. And others, they are polymeric based SPE chemically used here. So such as natural polymer, different type of polymers, and also ionic cation exchange cartridges for different specific type of applications. Right, so For the silica-based phases, so the pros, it has wide selection of solvents. It is inexpensive as compared to the rest. Huge applications on the market, and it is selected, it has selected solvent bases. And in plants, it has longer method development required. And then pH range, the stability is lower, and then it is prone to dry out. For the polymer-based phases, the approach with more functionalities, generic method development, and then high surface area loaded, capacity per loaded. Wide pH can be used, and it is resistant over drying. So the cons, fewer solvent selection, and it is very specific, and lower homogeneous surface and swelling depending on the solvents used. That's why, coming back to the method, it has very fewer method development, very generic, so it is very selective as compared to silica. Okay, so MIP, molecular imprinted polymerase. So this cartridge is something like the enzyme function. So it has a memory of a shape or a functional group of a template molecule. And then the molecular implanted polymer acts essentially as an antibody. So you have your target compound, and then it will just get into that polymer for the separation phase. The pros, very high quality and selectivity, high loading capacity, robust and stable, pre-refined method. So not much of a method development is required. The cost, the price, and only for selected target compounds. So it is very specific. Alright, the strategy. So we have two different types of strategy. So the bind immune and also interference retention strategy. So most of us will be using the first one, the bind immune. So it will retain the compound of interest while the matrix is discarded, and then the solvent is washed to eliminate undesired interferences, and then analytes are diluted finally in the pure fraction. So this is the most common strategy. It allows for matrix exchange and also analyze concentration. So let's say, example, you have 1 liter of wastewater. So 1 liter of wastewater, you can concentrate it within like 5 ml of your final pure fraction. So allows for matrix, also used to fractionate classes of compounds. So you can simplify your further down analysis by breaking down the fractions. Interference, another technique, interference retention strategy. Retain major interferences while compound of interest passes through the sample load. And then this is actually a less common strategy, and it is more common in the normal phase FTE. So it retains whatever interferences and passes through. So most of the time, the work that you do is not that simple. Pass through whatever your analytical, your desired compounds, and then trapping the interferences. It's not going to happen. So here, this is the one that will be used most of the time. Alright, so here you have 4 stages of FTE. You have your conditioning stage, loading, washing, and dilution. So these different stages, it will need different flow rate and different solvent volumes, different pressure in order for you to do it properly. So here, condition. So this is the solvation to wet and to activate the dry solvent. Equilibration to promote retention. So in this stage, you will actually need a fast flow rate. Okay, fast flow rate. Why a fast flow rate? So your cartridge, it may be kept in your cupboard or something. It may be in the warehouse of the dealer. So it has been a long time since it has been produced and until your facility. And it may have gone through the drying stage. So there may be dissolved air inside your cartridge. So for that reason, you need to condition the column with a faster flow rate. So fast flow rate is actually to push out the dissolved air inside the cartridge. So quickly, promptly, you push out the dissolved air, and then your cartridge will be ready for the next step. So if you do it slowly, if you don't have any control, you do it slowly, there might be some, I'm sure you have seen it, so there might be still some dissolved air inside that cartridge. So that is something that we do not want. That will actually contribute to a pure, to poor separation of your analytes. So here you need a faster flow rate. Loading step. So quantitative detection of analytes on solvent and also sample and first removing. So in this step, you will actually need a slow flow rate. Okay, why a slow flow rate here? In this stage, you want your analyte of interest to be absorbed on the solvent, right? So you need to move slowly in order for you to give time for it to absorb onto the solvent. So that's why here you need to go slowly. And okay, the first one, you have a fast flow rate, and also you should not dry the cartridge. So at the end, you must make sure that the solvent is on the top level of the cartridge. So you shouldn't go dry. So make sure the solvent is on the top level of the cartridge. And here you need to have a slow flow rate. Slowly, your analyte will interact with the solvent. And also, you must not dry the cartridge as well. So make sure it is on the top level. The washing step. So here, avoiding analyte solution. So here, you do not want the analyte to easily out. And removing of the residual interferences, dilution step preparation. So here, you can have a solvent drying. So here, you can have a fast flow rate. Okay, why fast? So the solvent that you use, it is not supposed to interact with your analyte, right? So it will still, your analyte will still be absorbed onto the cartridge. So you can have a fast flow rate just to push out all the contaminants that you have. So you push them out, you can have a faster flow rate here. And at the end, you can do a drying step. So here you can dry the cartridge. So why are you drying the cartridge here? Basically here, you do not want the washing solvent to interfere with your dilution solvent. So washing solvent, it can be aqueous. So you do not want the aqueous to be interfering with the dilution solvent, which may be organic. So you can have a drying step. You can have a drying step here. Maybe just push it with nitrogen gas, just like for 10 minutes, just to properly dry the cartridge. And then after that, you have the dilution step. So quantitative dilution of analytes from the solvent in a small volume of a pure solvent. So here you also have a concentration factor. So from being in a, let's say, 20 ml of sample, and then you will have concentrated down to, let's say, just 2 ml of sample. And then in this step, we can have a slow flow rate as well. Slowly you are taking the analyte out from the solvent and then into the pure solvent fraction. And some of the users, they think that, okay, so finally I want 4 ml of solution. But they do not want to do the 4 ml in one go. So sometimes they say it's better to do it 2 ml and 2 ml. So 2 ml is like activating the whole country or something. And then they just prefer to do 2 ml. They collect the addition. And then after that, again, they'll inject the 2 ml. So that is just a different type of technique in order for them to get a better result. So do you have any questions here? Conditioning, loading, washing and dilution step, and the flow rate associated with that. All clear? Alright, so negative pressure and positive pressure. So negative pressure, it is difficult to control the flow rate, difficult to apply the same volume from one sample to another one, and it has direct impact on recoveries and also reproducibility. So if you are doing manual SPE, so you are using a negative pressure. So here, in this case, we have no control over the flow rate. So you just on, vacuum pump will stop, and then it will just drop. So the droplets will drop probably the same pace on all the 4 stages of the SPE technique. So you have no control. So meaning that the recoveries and reproducibility is not really fair. Constant pressure, you have a much better control of the flow. Flow stays constant with the liquid dispense while pressure, it changes. And high reproducibility, which means limited variations between samples and also the packages. So constant pressure, it has better reproducibility and recoveries as compared to the negative pressure. Right, SPE pros and cons. So of course, SPE is not it's not a universal great technique. It has its pros and it has its cons. So it is efficient in isolation and cleanup technique, large application fields, so high selectivity, high recoveries, and good reproducibility, and it uses low solvent volumes. And then the difficulties, highly human dependent with expertise requirement. So a very experienced technician compared to a young technician. So you can see the difference. That you ask them to do the same experiment, same sample with the same concentration. Probably the experienced one, he knows where to control the flow, he knows how to do a lot of things. Compared to the young, so he just runs. Probably he follows the book and then he just runs. So it will take some time for them to develop that type of expertise. So then highly sensitive to flow rate control, dry state of the solvent, and also their reproducibility. So I explained about the flow rates and then the dry of the solvent, and also their reproducibility. It accounts for their reproducibility and perceived as long and fastidious technique. So it can be a very long technique in the beginning. So in the beginning stage, you have these 4 steps. So these 4 steps, you will need to identify the correct flow rate, identify the correct volume, and the pressure for that. So you identify everything. Once you set up the method, and the rest is just automation. The solutions use constant pressure to facilitate and to enhance control of the flow rates and also the drying step. Full SPE protocol automation. So we have solutions for the automations of these SPE steps. And Gilson, they are provider of the solution, so later I'll be explaining about these instruments that we have. The Gilson portfolio. So we have Aspect 271, Aspect 274. So earlier, when they made the presentation, when Mr. Mani made the presentation, he has mentioned 241 as well. So 241 is a smaller platform, so you can have one of your sample rack and one of your SPE rack. And then 271 is a bigger platform, so you can have like one of your sample rack and same time continuously you can do like 3 or 4 SPE racks. Okay, it's a bigger platform. So most of our automation customer, okay, I want to do automation. I want a higher throughput system. So might as well I just go for the bigger version, right? So instead of 241, they just, okay, go to select the bigger one, 271. So that's why the GX241 has been discontinued. So we don't sell them a lot, we sell the higher units. So no more 241. So we have the 271 and 274. So 1 is single probe, 4 is 4 probe. So you can do 4 SPE cartridges at the same time. So smart accessories, SPE mobile rest, and positive pressure caps, selection valves, So the valve rate, low pressure valve. So selection valve is mainly for the large volume. Dedicated control software, so dilution outage. So this software, I mentioned to you, SPE, you have 4 steps. So this software, it has those 4 steps, like name, condition, this is the condition steps, this is what it means. So it speaks the SPE language. It's not a common software, it's just a very dedicated software for SPE. And then manual systems for positive pressure and cold. We also have consumables and the aspect cartridges. So this is about Wilson press. Alright, so here, the core technologies of aspect. So aspect is our brand, SPE. So this is our brand for the SPE aspect. So the core technology, we have the positive pressure. So the collar, the cartridges, it will be closed by a cap. So you need to close, you need to seal it, and then leaving a hole on top. So the probe, the needle, will be dispensing the liquid. And then after that, there will be a pressure goes up in the collar. And the pressure equilibration, it means elution through the solvent. Air push to dry or not the solvent. So this actually contributes to the how we make up a positive pressure inside the cartridge. And then, or use external gas to quickly dry. So whether at some of the steps you will just want to use the air push just to dry a bit. Probably you will have some of the solvents on top. You just use a bit of air push to push the solvents inside. Or in one of the steps, which is the washing step, at the end of the washing step, you want to use a gas to quickly dry the cartridge. So that is possible as well. And then we have the mobile SPE rack. So in the conditioning, so we will drain all the solvents, the rack, which contains the cartridge, it will be on top of the drain position. And then load, we also want to drain the matrix, so it is on top of the drain position. And then, if you want to optionally collect the loaded the drain materials, so it is possible as well. The system, it will automatically move the deck from drain to the collection position. And then washing step. So during the washing, you will drain all the solvents at the draining position, and after that, you will move to the collection position for the elution step. So we have the mobile SPE rack to facilitate the automation of the SPE steps. And then the syringe pumps. So syringe pumps, we have single syringe pump, we have dual syringe pump. So single syringe pump, let's say you are just doing your normal SPE, so you have, let's say 10 mil or less of a sample to run. And then a double syringe pump, let's say you are using some internal standards as well. So you can have a smaller syringe, let's say 100 microliter syringe, and then a 10 mil syringe. So you can choose, the system will choose to use a smaller syringe for the standard, which is a smaller volume, and then a bigger syringe for the rest of the SPE set. And here we also have a pressure sensor to monitor pressure during the SPE process. So this is a 6-way valve. This is to control the SPE drying with an external gas supply. So this syringe pump is specifically for the SPE use with the gas. Okay, so we have that, those are the technologies, and we have the manual solution for that as well. So here, this is the aspect positive pressure manifold. The standalone SPE system with positive pressure elution. So this is manual still, but instead of using negative pressure, it uses gas for the positive pressure. So it can be used with 96 volt SPE plate, 1 mil SP cartridges, 3 mil, and also 6 mil. So there are maybe two different ways to allow a liquid to flow through the solid. So negative pressure, positive pressure. So you have been using the negative pressure, so you know the difference. And then this is the positive pressure that I have explained to you earlier. So of course, positive pressure, if you compare, even if you read a manual system, compared to the negative pressure, positive pressure will always lead to a better reproducibility. Okay, so this is a single unit for cartridges and also analysis for plate. So today you're using a 3 mil cartridge. So next time, let's say you have customer sample which they are using the 96 wall plate. So that is possible as well. You do not need a new instrument for that. You just need to change the pad. So here, you can change the manifold to become compatible with an M6 wall plate or a 1 mil or 6 mil cartridge. So just explanation, we have 24 positions for 1 mil and 3 mil, 3 positions for 6 mil, and 1 position for the M6 wall plate. So you have different collection racks, or different type of, different volume of the cartridges. And you have 24 positions for the 3 mil. But then let's say on that day you're only doing 10 samples. So you don't have to use all the 24. You can just use a plug to plug that position which is not being used. So you just use the position that you would like to use. So you have the slow flow rate and fast flow rate. You have the SPE steps and the drying steps. So we have dedicated SPE step. For SPE you can have low flow rate, high flow rate. For dry you can have a very fast drying step. So SPE, if you want to do the different steps, let's say conditioning step, you just turn the knob on the SPE, go on the high flow, and then you control the flow through here. Right. So anyway, this is still a manual manifold. So you still need an experienced SPE person who has hands-on experience with this, maybe around a few weeks or months, to have a very precise control of the flow rate. So you can control, it can be trained, so people can be trained to control the flow rate. But still, this is very much the technician dependent. So the technician, which has experience on this, when he's doing it, he can properly control the flow rate for different steps. Compared to a new person, he may take a longer time to actually gain control of the PPM. Right, features, it has single gas inlet with a maximum of 50 psi, easy setup, so single base unit for cartridges and also plates, so you don't have to get another unit for different dimensions. Fine pressure selection, constant pressure SPE, and it has dual position locator plate. So it is for limits the waste handling and also for the easy storage. So automated SP systems. So we have two different, same platform, but different throughput. So Aspect 271, you can place 5 racks there. So maybe one of them you can have for your sample, and then 3 of them for your SPE racks, and other maybe the final product if you want to transfer it into a HPLC vial, so that can be done as well. From the tube, you can automatically transfer to the SPE vial. So this is a single probe. So you have single needle taking one sample at a time and then processing it. And here you have 4 probes. So 4 probes meaning at one time you can process 4 different samples. So that is for the throughput. So if you have a lot of samples, then can go for the 274. And I mentioned the pump as well. So this pump, it has pressure sensor, and then single switch, double switch. This double switch, if you have 4 probes, you can use the double switch. You can get the 2 pump on the double switch, and then all of the switch, you can have same volume. So just 2 of the dual switch pump for the Aspect 274. Okay, so some overview. So compatible with 136 mil SP package. It is not compatible with 96 mil 96 volt plate. So you can have up to 5 SP solvents, and then 1 sample rack. So it can be dedicated to tubes or vials. And you can have 3 separate SP rack, so dedicated to 1 SP format. So 1 mil cartridge, 3 mil or 6 mil cartridge. So, and 1 additional rack here. So it can be, you can place HPLC vials, solvent bottles, and so on. Or another SP rack. So here, optional from single string pump to dual string pump. So you can have a smaller string and a larger string here. So you can have injection model here as well. Right, so typically it is the same thing. So here you can have up to 7 SP solvents. We can provide 4 reservoirs, and then 1 internal bottle and 2 extra solvent bottles. So to the off-bed solvent system delivery. 1 sample rack, and you can have 3 SP rack, same dimensions, and also 1 additional rack. So here you are using 4 probes, 4 needles at a time. So this is a higher throughput. So next, this is for large volume. So you have sample which is on the bed. So just now the first position, you can have your sample rack. And then you can have off-bed samples. Let's say you have 1 liter of sample. So that can be off-bed. So we use the valve mate, equipped with a low pressure valve to aspirate large volume sample. So this is the valve, and your sample bottles, it will be placed on the floor or on the side of the instrument. So the valve, it automatically switches to aspirate the correct sample, and between each sample, the common tubing is optionally rinsed with an organic sample. So this is a 10-way valve. So you have one for the clean water, others for the organic solvent, one more position for organic solvent, and you have 8 more positions for the sample. So for 271, you can do 8 samples without interference, without human interventions. And then for 274, you have 8 times 4. So you have 32 samples which can be done without human interventions. And then also, when we deal with large volume samples, large volume of wastewater, so you have a large volume of aqueous and some volume of organics as well. So we have dedicated racks to separate. So here you see you can have 2 outlets here. So you have dedicated outlet for the deck and for the organic solvents as well. So basically the same on 271. The main difference is you will add on a valve mate, and then you can aspirate samples from different bottles. This is a 4-probe system. Right, so the software. So here, our Valuation LH software, a lot of our customers, they are very happy with the software because it's very easy for them to just set up everything. And as I mentioned, it speaks the SP language. So first, it has the conditioning task, so clear here. Right, so it has the typical SP task, like conditioning, loading, washing step, and also elution step. So conditioning, okay, you need to clean and wet the solvent and adjust the language. So here, the key parameters control for a high reproducibility is you do not want to dry the cartridge, and you have a good solvent soaking. So there are dedicated parameters there for that. So you have control of the flow rate, you have control of the equilibration time, just nice for it to be on top of the solvent, to be on top of the solvent. And then if you need any air push, let's say it's too much on top of the solvent, you can push a bit of air just so that it will be just nice on top of the solvent. So soaking time, residual volume, and solid phase control here. So for the sample loading, load the sample, and you need to have the maximize binding interactions between your desired molecules and also the solvent. So here you need a precise volume and also for the flow rate control, and you can control all that in a simple parameter. Aspiration flow control. So if it's viscous, you can have a slow flow control, and if it's volatile liquid sample, you can have different flow rate for that as well. So you set up the method, so you know, okay, this is a viscous sample, I use this method. If it's a volatile sample, I use the other method. So you set it up, and then after that, it's just for execution. Here, for the washing, we have a strong drying step here. So you can use the switch pump, the valve, to dry the cartridge. So dilution, so here slow flow control and volume splitting is possible as well. So you just control everything to the dedicated parameter for that. So that's why I say this is typical, and then it speaks the SB language. So automated aspect system strength. So full SP protocol automation with the mobile rack technology. So whenever you need it to be on the drain position, the system will be automatically pushing it through the drain. And after that, if you need it to be on the sample rack, so sample position or the collection sample position, and then it will be pushed to the collection tubes. So bind inlet or non-retention strategy can be imposed. Fractionation of multi-dimensional SPE, like 2D SPE. So you can have different types of cartridges. So in this example, one charcoal has been used in one part of the rack, and then another part sodium sulfate. So different type of cartridge, but it is in the same protocol. Automated method development. So I mentioned that our software, it can speak the SPE language. So it has four. You have your conditioning step, loading, washing, and dilution step. So let's say your washing step is perfect. You have perfectly developed the method. And now you just want to concentrate on the dilution step. So you can just delete from that method. You can just delete the dilution step. You can just delete the rest of the step and only concentrate on the dilution step. So that is possible with the software. So that's why a lot of our customers, they don't really waste a lot of time developing the whole method for that. So they perfect some of the steps. So only certain steps they need to use. So they just concentrate on that in the software. Accuracy and reproducibility. So full control of the SPE key parameters. So SPE, it is under positive pressure. So precise switch pump control. And you can control the drying state of the solvent. So you know, some of the stage you have to have a dry solvent, like in the washing stage. And some of the stage you cannot dry the solvent. So all of that can be controlled here. So aspect system highlighted SPE applications in food. So even earlier, Jagan has been talking about the components, the applications of different type of compounds and in the food sector as well. So here you have different type of contaminants like mycotoxins, neurotoxins, phytotoxins, veterinary and aquaculture drug residues like antibiotic, antiparasites, and PFAS, PAH in seafood or oil, pesticides in milk, toxic compound from feeding processes, and then nitrosamines in red rice water, nutritive and gastro-free qualitative value like lipid fractionation, vitamin B12 in human milk, and the rest. So you have been in the food industry for long, so you have your applications as well. So mycotoxins, he also explained about aflatoxins, antioxidants, and caffeine. So they are toxic compounds, so poisonous carcinogens, and they're naturally produced by certain types of fungi present in cereals, fruits, nuts, spices under environmental stress conditions like different temperature and humidity. And it is analyzed by animals, and it is present in milk, in eggs, and other food products. So stable, and it is a potential contaminant in the food stock chain. So we do have a lot of standardized SP method for isolation of mycotoxins. And in the European countries, this is like a huge standard for them. This is a huge problem for them as well, to isolate mycotoxins, to identify mycotoxins in food. So they have classic phases like silica-based HLB, and then polymeric HLB, classic SP protocols, it is highly selective, and the polymer phases, it has high stability with pH and also organic solvents. And another one, immunoaffinity gels. So they are very high specific towards the monoclonal antibody, and very similar to SPE without the conditioning step. So it is sensitive to contact time and also to organic solvents here. Molecular imprinted polymers, MIP, they are polymers with memory of the shape and also functional groups of the template molecule. It has high affinity and also selectivity. It is robust and it has stable material. And classic SPE protocols with limited method development is required here. So different types of immuno and immunoassay methods used for immunoaffinity for sample cleanup. Okay, so here we have full automation and throughput. So we have the mobile rack technology. Even a 50 mil plastic tube, it can be directly transferred onto the GX aspect system. So you don't really have to transfer it into a different type of tube just to fit the surface standard rack. So we have so many different type of rack. So you just have to mention about the tubes that you're using, and then we can just propose the same that specific rack. And let's say your tube is out of the ordinary. So it's a special tube, we can also customize the tube. But most of the time, we will be trying to use the readily available standards. And then ability to use large range of sample volumes, like from mils to 50 mil or more. So efficient and reproducible contact time, low flow rate control, like switch pump water, and not gravity or vacuum. And here, a fractionation of elution into 2 parts to improve contact time and also recoveries. So neurotoxins is shellfish. So paralytic shellfish poisoning, like for toxins and also its analogs, highly potent neurotoxin, severe illnesses in humans. No antidote listed in the Chemical Weapons Convention, and naturally produced by microalgae with contaminant shellfish by ingestion. So this is a global worldwide expansion, so multi-factors causes, but not yet well identified. Example like climate change, increase of global marine traffic, fertilizers, renewables, and so on. So here, to identify this, it uses the plastic SP method as well with C18 or SCS. It has standard regulated methods for the AOAC methods. So this is just a scheme to mention whether you need to choose SP or different type of pathway. Okay, key success. So here we have the multi-collect functionality. So our software again, so it doesn't just speak the SP language. It can do many other things as well, like fractionation. It is not really in the SP step. So it can do fractionation, multi-collect, it can do liquid transfer from tube to tube as well. And then, so 271, 274, according to the throughput, the flexibility, so non-SP task is available, and automation of periodical oxidation. So using a coated probe, it's available as well. So we have different type of probe for different type of application. So here, perspectives and also for the future methods, PSP, SP carbon healing MSNS method, it has been identified, and there are a lot of somewhat new neurotoxins present in the Europe as well, like the tetrodotoxins. So initially it's only present in like Asia, and after that we went to the European countries as well. And here we are just putting on some of the success stories, which we have been working with some of the universities, and they have been using our systems to identify different type of toxins, different type of applications with our system. Agricultural drugs, nitrofurands and chlorphenicol. So it is a class of broad spectrum antibiotics. The human toxicity, hematological abnormalities, aplastic anemia by food ingestion, and it used to kill or slow down the growth of bacteria in the aquaculture industry. So it is banned in Europe, US, Europe, and China. And it has complex matrices, highly sensitive and robust, good analytical method, and throughput requirements. So here, US FDA, they have developed a method using our Aspect 274. So this is one of the methods to identify the drug. Okay, so here they have used the HLV 3 mil package as well. So these are the SP protocol steps. So some of the key success for the nitrofurands application. So ability to produce reliable result with perfect control of the SP key parameters. Again, so ability to ensure high throughput using the Aspect 274 system. So 274, it has 4 probes, so 4 samples processed in parallel. So fast is the transfer of the dilution methods to several different Aspect systems. So you have one in CTA, and then you can transfer the same method to CT.
I just want to know how this, molecular imprinted polymers are forming.
Are forming?
Yeah.
Okay, so it's as similar like enzymes.
Okay.
Right? Enzymes, they target a certain molecule, right? So same like this. So MIP, it has very specific target. So that's why, as I mentioned in the slide, it is very specific and it doesn't apply for all the applications. So only certain applications, you try to use the MIP and see if it can catch your target compound.
Okay.
So if you just Google MIP, it will give you a list of compounds which it has a specific binding spot for that.
Thank you.
It's very specific.
Any questions?
In automated SP, is there separate injection port is there to take the sample and keep in cartridge?
Okay. So on SPE, you want a separate injection port. So it uses the probe for that. So it uses the same probe for the sample, and then it injects on the cartridge. And after the injection, it will go to a specific place to wash the probe. And that probe, we have the inside wash and outside wash. So two different ports to wash the inside part of the probe and also outside part of the probe. So cross-contamination is minimized for that. And if you want a more, okay, so you think, okay, this might still be having cross-contamination. So we have another pump for jet washing as well. So that is another port. You add this pump just to use a high flow rate to wash the probe.
You have a video saying the specs will be solid waste specs.
Okay, I don't have it here, but then if you're interested, you just have to go to YouTube and then type out Gilson SPE. So Gilson Aspect System or Gilson SPE 271 or 274, you can find a lot of videos of that.
If you
So just like I mentioned, there is a smaller volume range, so you can use that to spike the sample as well. So you have the rack and you have the spike material, and you want to spike certain volume, right? So you can transfer that volume onto that all the samples that you have. So it can be done as well.
say.
Okay, thank you very much.
Thank you.
Thank you very much. Now I request Adhoba sir, out of thanks.
Hello everyone. I am so happy that I am here today with all of you. You are all distinguished personalities from the food industry, food analytical industry, food testing. So you know the food analysis much better than anybody else. I would say like that. Today, actually I was reading, food industry is one of the largest growing industry in the market. It's really showing rapid growth. Just one thought came to my mind, I would like to share it. Say 30, 40, 50, 60 years before, our mothers and grandmothers, they were making conventional food in our house and we were not consuming food from outside market. But today if you see, even a 1-year child, he knows which brand of ice cream is available, which brand of chocolate is available, which brand of cakes are available. So such a tremendous growth in the food industry. And of course, lot of conventional products, they are modified by different experiments, maybe by different blending, adding something. And you will find today, right from sweets to spices and dosas to donuts and curries to cakes, everything is modified. Everything is available in the market. But with such things coming into the market, I think the food safety is also important. Because ultimately, we consume the foods and that directly connected with the body chemistry. So contamination if is there, definitely it is going to create the disease in our body. So from that angle, food analysis is the most important in this industry. Actually, as far as analytical techniques are concerned, definitely you have a lot of accurate and reproducible techniques. You have sensitive techniques like LC mask you are using, HPLC with different detectors you are using. But most important as far as food is concerned is to bring the desired component or maybe the targeted analyte into the sample form or into the injectable liquid solution form. And that is very critical because the food matrix is very complex. The food matrix is very complicated, and that is where this thing comes into the picture. And that is where Gilson aspect systems come into the picture. Today Gilson has captured really good share in world market for these aspect systems because of their excellent, I would say, the cartridge chemistry or maybe the advanced instrumentation technology or excellent application support from Gomati in our area. So that is why Gilson products have become very, very popular in last few years into the global market. I thank Gomati. Dr. Gomati came here all the way and she gave an excellent presentation. Wonderful. Because please give a big round of applause. Because you covered not only the instrumentation, but you covered the fundamentals of adsorption, chemistry, and also you covered certain application data sheets, mycotoxins and all. It is very interesting, I would say. Thank you very much, Dr. I also acknowledge Dr. Jagan, who gave the glimpses of our certain instrumental range, which are related to the food analysis. Thank you very much, Dr. Jagan. I also thank Mr. Mani, our Vice President, South Region, Branch Manager Mr. Shriram, and all Chennai team for organizing such a good seminar. I thank Mr. Poddar, my colleague and our Executive Director for coming here. And lastly, I would like to thank all of you for sparing your valuable time for this seminar. And I tell you, I assure you on behalf of our company like Anatech and Suntech that we will keep on offering the excellent services to all of you as we are offering for the last so many years. And that is our job. So even I tell you, somebody asked me about the demonstration, I think, whether such kind of demonstrations are available. Of course, as of now, we don't have any unit for demonstration for Gilson product, but very soon probably we will be having such unit in our laboratory. We have an application laboratory in Mumbai where we have kept quite a few JASCO instruments and also certain instruments like smart evaporators or even JASCO CD polarimeter. All those instruments we have kept. And recently I can tell you, as far as when the word came as smart evaporator, we have really sold a lot of smart evaporators because of the demonstration unit available in our lab. I think one such unit is available with your office also, Chennai office also. So you can, if anybody is interested, please ask Mr. Mani. He can arrange the demo at your office or he can bring the unit to your lab. Because smart evaporator is one which is really useful for any kind of industry. Basically it is like you want to take a sample in a powder form or you want to concentrate your analytical solution. So it is very important product. So that is available for the demonstration. So I really thank you all for coming over here, sparing time, asking questions. That's really great thing. And maybe now the lunch is ready. Yeah, so I can invite for the lunch. You'd like to say
Yeah,
something?
finally, just I want to thank you, all of you. And we are trying to generate a good database in the food industry. We have long experience in working with pharma companies because pharmacopoeia is very clear, which mentions what are to be done. But food regulation is getting stringent and stringent. And all of you are very, very important for us because we are learning from you like what things we should develop. like now aspect she explained you, and we would like to promote that with all consumables which we have. So please do interact with us. Maybe some questions will enlighten us, and we have a chance to learn from you. And I think India is going very strong in the food quality maintenance. So this is good for us to serve you, and your participation will be very, very useful to us. So any questions you have, even later, you can mail to us or you can write to our branch. And thank you very much for coming here, and thanks for your support. Thank you very much.
Have a good photo and go for lunch.
Yeah.
Whatever. Group photo.
Bye-bye.